Hello Algebra 1A students, this is the video on graphing inequalities. What I'd like you to do is I would like you to copy down the 3 examples we're going to do. You can just sketch your number line. If you want to take a second to pause the video and do that, you're going to need 3 number lines. Our first problem is going to be x is less than 5. Now, this inequality tells us we want a number x that's less than 5. There's lots of numbers x that are less than 5, like 4, or 3, or 1.2, or -1, or -1,000. Okay, there's lots of numbers that are less than 5, so that's why we have to graph it on a number line, because there's an infinite number of solutions here. 5 is going to be our boundary point, so let's go to 5 here. Now, when it says x is less than 5, is 5 included? Well, let's look. Is 5 less than 5? No, that's not true. 5 is not less than 5. 5 is equal to 5. So we know it's not going to be included. The way we show that it's not included is by putting an open dot on 5. That kind of shows that the numbers around 5 might work, but not 5 itself. Okay, so open dot means it's not included. Okay? Okay, so now we have our boundary point. Now we need to figure out, does our arrow go to the right or does it go to the left? Well, let's think about this. X less than 5, the numbers less than 5 are in this direction. So we're going to draw our arrow in that direction. If we do it to the right, well, 6 is not less than 5, neither is 7, 8, 9, or so on. Okay? If you wanted to check your work, you could pick any random number. Let's do -7 on your solution. Is -7 less than 5? Yes, it is. Check. Okay, so here is how we graph x is less than 5. Okay, 5 is not included because it's strictly less than, and then all the numbers less than 5 are in that direction. Okay, all right, let's try another one. Let's try x is greater than or equal to 1. Okay, well, we can think of lots of numbers that are greater than or equal to 1, like 5, 10, 100, okay? That's why, again, why we need this number line. So our boundary point is going to be 1 this time, and it says x is greater than or equal to 1. Well, let's see if that boundary point is included. Is 1 greater than or equal to 1? It is because of this equal to. So we are going to put what we call a closed dot or a filled-in dot on 1. That means that this boundary point is included. Okay? Now we're looking for the numbers x greater than or equal to 1. Well, is 0 greater than or equal to 1? No. Is 2 greater than or equal to 1? Yes. So we know our arrow is going to be going in this direction. Okay? This is the graph of x greater than or equal to 1. We're going to try a little bit more complicated one. We have -3 is less than or equal to x, which is less than or equal to 6. Oh, wow, we have a couple things going on here. But what we're saying is we want both of these things to be true. We want x to be greater than or equal to -3 and less than or equal to 6. Well, I can think of 1 that's greater than or equal to -3 and less than or equal to 6. Okay? So we have 2 boundary points which we're going to work on here. So -3 is one of our boundary points. Is it included? Yes, it's included because there's an equal to there. So I'm going to go ahead and put a round dot on -3. 6 is another one of our boundary points. Is it included? Yes, because it's an equal to. So I'm going to put a filled-in dot there. Now, if we want x to be less than 6, we know it's got to be this way from 6. And greater than -3, we know it's got to be that way from -3. The only area where both of those things are true is right here in the middle. Okay? This is the graph of the solution -3 is less than or equal to x, less than or equal to 6. Okay? Please make sure that you write down any questions that you have and bring them tomorrow along with this piece of paper with the examples. Thanks, guys. Have a great night.